Arithmetic, this word that we have heard time and time again. But the thing is, this is not always defined. So, it is literally just these four. Not just any math, it's specifically just adding, subtracting, multiplying, dividing. It comes from the Greek word arithmos. And arithmos literally just means number. So these are the four basic things that you can do with numbers, and that actually essentially becomes everything. So all of calculus is essentially just fancy adding, subtracting, multiplying, or dividing. Algebra, same thing. Geometry, same ideas. So this is the basis of what you can do with numbers. Therefore, it is derived from the word arithmos, or logos arithmos, which just means number. All right. What's the significance of it? Well, because of the fact that it is the basis of everything, it will help us, define everything. And we'll kind of see how that goes throughout this year, and you'll be able to understand pretty much how does adding basically make everything. So like in calculus, there's this thing called an integral. This is just really, really fancy adding. You don't see it, but it is. And then derivatives, this thing, ddx of f of x, that's actually just really, really fancy division. You're dividing things, you're actually getting slopes here. Also, the adding thing up there is also kind of multiplication, but remember, multiplication is also just fast and fancy adding. Alright, so we're going to use these and kind of try to use intuition to understand what exactly is adding, subtracting, multiplying, dividing. That'll be important for understanding basically, everything. I know it's going to seem a bit mundane, at least with addition and subtraction, maybe multiplication. Division would be a little more interesting. Let's just try this now. 2 plus 3, what that really means is you're combining 2 and 3 together. So the question is, how many dots do you have as a result? Well, if we take that, and we take that, you put them together. What do you have? 5. I know, super difficult, right? We have 5 dots. So that means 2 plus 3 equals 5. Okay, simple enough, right? So let's look at subtraction. What it really is, there are two ways. You can kind of think of it as taking away. So you're taking something from something. Or you're saying from something, take away something else. That's more of the syntax that we have. 5 minus 3 means from 5, take away 3. So that part's really important, the from and the take away. So let's look at that. If we take 3 away from 5, I'm just going to get rid of those. What's left? We got 2 dots. That's all we got left. So that means 5 minus 3 equals 2, or 5 take away 3 equals 2. All right. So that's the taking away way of thinking and looking at it. So now distance. You probably have not really thought about distance that much. So 5 minus 3, let's look at that. So the thing is, we want to get to 5, and we're going from 3. So 3 to 5. That's what we're really looking at. So let's just kind of look at that on a number line. So starting at 3, how do we get to 5? Well, if we just hop up by 2 units in the positive direction, we get positive 2. So 5 minus 3 is positive 2. Well, what if we reversed that? So how do you start at 5 and end at 3? Well, it's very similar. So starting at 5, I'm going to make that green, and then ending at 3, making that blue. It's still 2 units, but what changes? What changes is we go the opposite way, the negative direction. So we go minus 2. By the way, adding and subtracting and positive and negative, they're kind of related. So negative just means direction. So make sure that you just think of negative and positive as different directions rather than like two different weird mystical things. So go 2 to the left, so we get negative 2 or minus 2, however you want to call it. All right. So if we just look at this, we kind of see it's not too difficult. Distance versus just the taking away mentality. Think about them both. They're very useful, both of them. So the next thing is multiplication. Just to simplify it, a times b means we want a to happen b times, or you can think of it as we want b to happen a times. Commutative property, they mean the exact same thing. So looking at an example over here, 2 times 3 means we want 2 to happen 3 times, or vice versa, we want 3 to happen 2 times. So how many dots do we have? So I'm going to just make that come over. So, okay, it's being weird. I'll just get the dots. So, okay, so we want 2 to happen 3 times, so I'm just going to copy that over. So it's happened once, all right. And then let's copy that and then make it happen yet again. All right, then with that, another time has been used up, so I'm going to erase another one of the things in 3. And then yet again, just going to copy it. Whoops. Going to copy it and do that a third time. And then now we can erase the last one, which means we're done. So how many dots do we have? We have 6 dots. So that means 2 times 3 equals 6. All right. So not too bad. Pretty intuitive so far, I hope. If not, pause the video, watch parts a few times. Now let's talk about division. This one is the thing that gets interesting. So a divided by b, or a over b, get used to the a over b thing, means how many b's do you need to add together to create a. So you can kind of think that a is your target, b is each unit or step that you're taking. How many steps or how many units of b do you need in order to create a? And yes, you can get fractions from that. You can get part of something. In this case, we're not going to do that just for simplicity's sake. All right, 6 divided by 3. We all know that that's 2. But let's look at it this way. How many 3's do you need to add together to create 6? So if we have 2 of them, and I'm just going to flip that a little so that we can make it look exactly the same as the other one, we'll see that we get 6, just with 2 sets of 3. So what we're looking at with division is that number of sets. So that's why 6 divided by 3 equals 2, because 2 sets of 3 equals 6. So division, the basic question is just that. So think about it that way. That'll also help fractions make a lot more sense, which will be discussed about in a later video on doing arithmetic with fractions or rational expressions. But yeah, so 6 divided by 3 equals 2 because of this exact reason right here. Okay, so not too difficult, right? And pretty basic idea of looking at it. All right. So one thing I want to talk about in this very last part is multiplying and dividing negatives. So I know that we memorize rules like a positive times a positive is a positive, a negative times a negative is a positive, a negative times a positive is a negative. So what it really means is change of direction. When you multiply, you're changing the direction of something because you're saying how many of something is going to be happening in what way. So here, you're basically saying, let's go in the negative direction, and then how many of that negative is going to be happening. So when you do that, you kind of go one direction, and then you switch direction whenever you negative something. That's why negative times negative is positive. And then if you go negative and then multiply by positive, you're just saying basically go negative, and then the positive means to stay that direction. So you never change your direction, you're just going. So essentially the number of negatives is the number of changes you make. So in the first one, there are 2 changes. In the second one, there's only 1 change. So you can think about things going positive first, and then when you change it, then it's going negative. And if you change it again, it's positive again. If you change it again, it's negative, positive, negative, the number of changes. So that's pretty much it with positives and negatives and multiplying and dividing them. Just think of them as direction, and then things will be good. ご覧いただき